So next up, we're going to talk about another way of storing data within Azure, and that is through a proper database. If I go into the marketplace and I go under databases, we can see that there's a number of options that Microsoft is offering to us. Now, the one you might be most familiar with is SQL Server running within Windows. So this is a virtual machine, just as if you had a computer next to you with SQL Server 2017 Enterprise installed. There's many different flavors of SQL Server. You can also bring your own license if you have a SQL Server license and save some money that way. But basically, having SQL Server running in a virtual machine is perhaps the most similar situation you have to SQL Server running in your own environment. So if you're going to do a migration from the SQL Server running in your data center to Microsoft Azure, this would be the simplest approach, right? Just getting it up, getting a SQL Server running in a virtual machine, and then you do the data migration, and you are almost the exact same situation you were before, just running with a different server. Now, that might not be the best approach, and it's certainly not the cheapest approach, but it is perhaps the most familiar to you if that's where you come from. The version that Microsoft wants you to really consider is called Azure SQL Database. Now, Azure SQL Database is a database as a service solution. It basically looks and acts very much like SQL Server. There's a high percentage of compatibility. So if you have a database that's running in SQL Server within your data center, getting that migrated into SQL Database for 95+% of you is going to be basically no trouble at all. You're not using any of the advanced features that SQL Database doesn't support, and so you're just able to migrate your data, point your application to the SQL Database, and move on with your life. Now, SQL Database is a lot cheaper option. There are different pricing options, and we'll go over them in a second. But it actually does save you money compared to a virtual machine and all the costs associated with that. So when you're looking at this from an exam perspective, even from a real life perspective, you really should look at SQL Database as being the best solution for a lot of the situations out there. And really, the only situation that you need a SQL Server in a virtual machine for is something where you're like tuning the settings within a hair of its life, or you're really trying to squeeze out the extra performance on the CPU, and you've got that memory dialed in to just the perfect amount. If you really do need to configure the hardware and the settings to that degree, then you might want to continue on with that. There are also some advanced features with collation and the way that it does full text indexing and things like that that SQL Server, a SQL Database doesn't necessarily support. Now, Microsoft also provides a managed version of this SQL database. So if we go through the SQL database route, you're going to do all the setup, you're going to migrate the data, and you're basically responsible for managing the performance. If the database, if you need more performance out of it, moving to the higher plan. Migrating between plans is super simple, and we're going to look at that as well. But the managed instance basically lets you to migrate the data and let Microsoft take care of the scaling of it, etc. We also have data warehouse for those data warehouse and reporting situations. Data warehouse is designed to support, tons and tons of data, the size of the data. You're going to use something like a data lake to report into a data warehouse. A database pool is part of SQL Database. We'll cover that. Now, besides the SQL Server compatibility version, which is called Azure SQL Database, you'll see that there are 3 other databases that Azure provides that are in the same fashion with Azure SQL Database, but you can have MySQL Database as a service, PostgreSQL as a service, and now I think this is in preview, or perhaps it's available, MariaDB as a service. So if you're relying on any of these database types for your application today, and you want to migrate into Azure, other than having a virtual machine with these softwares installed, I think MySQL is also available as a web app. You can have them as a database as a service, a software as a service type product here. So in this section, we're going to go through setting up Azure SQL Database. We're going to create our first database server and then the database inside of that. and we'll do something similar we've done with Cosmos DB and the tabled storage, in which we're going to start programming a little bit against it to show how compatible it is. The commands for dealing with this are the same ADO.NET that you've been using up till now. So we'll start on with the coding, but it won't be anything that you hopefully haven't seen before in other situations. So in this section, we'll talk about Azure SQL Database as a place to store structured data using relational databases. All right, so let's choose the SQL Database option. Now, I alluded to it in the last video, but there's two concepts here. There's the database server and the database itself. Just like in Cosmos DB has an account and a database as well. So let's call this database AZSJD new DB. Okay, this is the database name within our Azure account. I'm going to put this on my usual subscription. I only have the one. Again, this is going to be different for you if you have the free plan or the MSDN or your corporate plan. We do have to put this into a resource group. I'm going to put this into SQL DB resource group. Now, we do have the option of starting with some data in it. So AdventureWorks has been a long time sample database in a lot of Microsoft projects over the years. So we do have the AdventureWorks LT database available if we want some sample data. We can also point to a backup file. So if you've got a backpack file that's been backed up from your database, let's say at your SQL server in your local environment, you want to back that up into a backpack file, there is the option for you to restore that database into an Azure SQL database right within this setup. Now, I wouldn't necessarily do this during the setup. I would start as a blank database and then create that import after. But we do have those three options when we're creating it. Now for the server. So this was the database, but database has to live in a server. I don't have any SQL servers, Azure SQL databases that are ready to go, so we're going to create a new one. Now this one has to be fully qualified. So this server, I can call it the same name, even AZSJD new DB, because it's .database.windows.net. So this is by default publicly accessible database that if you have the URL and the right access credentials, you can, and it's opened, you can connect to it. SQL Server in SQL Database uses a firewall method in here. We're going to get into that later, but basically you're going to have to whitelist people who are going to be able to get access to this. But if they're in the whitelist, then they're going to access it using this URL. So just like with a virtual machine, you're going to have to give an administrative username and password, and pick a physical location, a region around the world where we want this database to live. Now remember, I said that this runs on a firewall metaphor, and so there's a checkbox here that says, do we want to allow Azure services access to the server, which is basically opening a hole through the server firewall to allow other Azure services through by default. Okay, so we can turn that on unless you have a really busy account and you want to protect this particular database from other people. Okay, I'm going to say select. So we have our blank database AZSJD new DB. It's going to be on the brand new server. Now, this concept of an elastic pool, this is when you have, maybe you want to have multiple databases that are sharing resources. So databases can be a little bit expensive, and if you're going to have, like, let's say your company has 20 databases, well, you can set them up as 20 single databases, and they all have their own individual resource allocations. Those are single databases. But if you put them into an elastic pool, you can basically reserve a set amount of resources that all 20 databases end up sharing. Now, you can save some money with this, assuming that those individual databases are not all maxed out using maximum resources at the same time. So if you've got one database that experiences a surge, but the other databases are quiet, this is a way of having the resources shared between it, just like a pool suggests. Because this is a standalone database, I'm going to say not now. This is not economical for a single database, only when you have multiples. Pricing. So just like a virtual machine, we're going to be given options in terms of pricing. Azure has a basic, standard, and premium in terms of this type of pricing model, which is by performance. We're going to talk about purchasing the resources in a second, but there's two ways of basically purchasing SQL databases. One is by performance. So this basic environment is 5 DTUs, which is a database transaction units, and just like with web apps, using DTUs is going to be basically a way of comparing the performance. So if we got 5 here on basic, if you get a 10 on standard, that's a double, you would expect double server performance, okay? So it's just a relative metric between different accounts. If you need 500 on the premium plan, that should be 100 times more powerful than the basic, and you would see that the pricing, $2,600 compared to $7, is also pretty fantastical as well. Now, premium has additional features beyond standard, but if you're looking at the DTUs, you're basically paying for performance. Now, that's one way of purchasing servers. The other way is what's called a vCore, which is by purchasing the core of the CPUs. How many CPUs you want? Do you want 2 cores, 4 cores? How much data do you need? 4 cores with 168 gigabytes and 50 gigabytes for logs has a price. So instead of purchasing, Microsoft giving you a performance guarantee or a performance promise, you are not getting that. You're getting a dedicated set of CPU, 4 virtual cores of a CPU, or an 8 virtual core CPU, how much data, and there's a price associated with that. You can also choose between generations, so generation 4 and generation 5. You would expect generation 5 is more performant. It also supports up to 80 cores, so if you've got a database that really needs 80 cores of CPU, you are looking at $21,000 a month. Okay, the price is per core. You can see it's the same price for generation 4 and generation 5. So there, you can actually purchase your database based on CPU and data, or just basically say, you know what, I just need a basic database and I'm willing to pay for the performance. I don't care how many cores, I don't care how big a memory store, as long as you can deliver me this performance. So I'm going to buy the 5 DTUs. It's the cheapest. There you go, $7 Canadian a month. It's about $5 US a month. I'm going to say apply. You only get the choice of this collation. I think if you are using different types of collation, then I would suggest looking at SQL Server. Look into. Hopefully the default collation is good for most situations. So you see there's some complexity there, setting up databases and setting up servers. I'm going to hit the create button here. We'll get into it, but I'm going to pause the video. When we come back, we're going to have a working SQL database and we can start playing with it. All right, so we have our SQL database that got created. If I go into my resource groups and I type SQL, I can see the resource group that I created. And 2 resources are living in my resource group. One is the server itself. This is where we assign the URL, for instance, and the database, which is where the data, the tables, and the functions and the store procedures and things are going to end up being defined. Okay, you can have multiple databases running on a server. Now we can check the deployments real quick. We can see that it took 1 minute and 38 seconds to create this SQL database. So it's pretty quick. We're just a tenant in an existing infrastructure Microsoft has. Okay. So let's choose to go into the SQL database. So we're going to choose SQL database. Now we do have some elements, even though this is a database as a service, Microsoft does tell us the amount of the resources that we're using. So remember, we signed up for the basic plan, which is 5 DTUs. And so if we find ourselves running at high resource utilization during peak periods, we may want to consider upgrading to standard 10 units or other options, right? Now we can see, even on the home page, we can see our storage used because there's max utilization of 2 gigabytes under this plan. And we can actually start to see some of the settings that we have in terms of performance, in terms of backup and recovery, georeplication, and the different security settings. So this is all sort of on the home page here. Now, databases, just like a SQL Server running in your environment, are connected using connection strings. And so we could click on this, and Azure will give us the connection string. Depending on our language, we can see how to connect to this within our application code. Okay. Now, very similar to Cosmos DB, another advantage that SQL database has over running a SQL Server in a VM is how easy it is to get georeplication going. So right now I have a single instance of my database running in Canada East. There's no other backup storage that's being put all over the world, for instance. But if I wanted to, I could set up a georeplication, and then that would be another point at which applications could read. So it becomes a read-only location. On the map, we have a purple region. That's going to be the highest speed option, and then any of these green regions we can also deploy our georeplication to. So let's go into the regions here. Scrolling down, we can see that I'm running in Canada East, and I can choose Canada Central as a secondary location as an example. Okay, so it's going to have the same database name. It is a read-only database. I would have to create a new server. So just like I have the server running in Canada East, to create the server in Canada Central, I'll just have to go through that blade. It's not Elastic Pool, and it's going to be the same pricing tier as the main. Okay, so create a new server, call this AZ SJD new DB, which is already taken, of course, BKP for backup. And I give it the administrator. And so I can basically create a server just like I did for Canada East in Canada Central. Okay. So Microsoft Azure is going to take care of creating the database in Canada Central and keeping that database up to date. So when I do a write in Canada East, that data gets migrated and replicated into Canada Central as quickly as possible. It is not instantaneous, perfect replication, but basically there's going to be a low latency when a event happens and a transaction happens in Canada East. That data gets into, in this case, Canada Central. I should say too, now I am paying for 2 servers. So the $7 a month I was paying for Canada East, I am now times 2 because I'm paying the same for Canada Central. This is not, nothing is free, right? So now theoretically I could deploy this now into Europe. I can deploy it into Asia. My applications could be intelligent enough to know that it would be quicker if the application's running in Asia to look up the data in a read-only fashion from the Asian environment than to have that come to the Canada environment to get that data. So we can actually program our applications with these multiple endpoints and have them geographically aware to say, oh, in this region within so many thousand kilometers or miles, we're going to connect to this database. Okay, so that's totally up to you as an application developer to say which one you connect to. But in this configuration, it's a read-only instance. Now, the other benefit of this is the failure, right? So if Canada East, for some reason, whatever reason, the data was to get corrupted or the region was to go down, there was to have some sort of technical issue that I cannot access Canada East anymore. Once this Canada Central is up and running and we can see that the database has been migrated, we can force a failover. There's a way of basically instantiating failover into Canada Central, and then Canada Central becomes the primary database, and Canada East is taken offline until it can be replicated or repaired, right? So the georeplication, not only for performance in terms of reading, but also for failure in case of disaster, you know. So this is the purpose of georeplication. All right, so far we've been looking at the database level. So this is what is presumably going to contain our data. We can even see that there's a browser-based query editor that we can then connect with our username and password into to see the database. But before we do that, we want to look at the server. So we go to the overview screen. We can see that this is the server that we created. We could also go back to our resource group to look at the server as well, but I'm just going to click on this server name. It'll take me up to the server level. So the server is basically that is the place that hosts the database. And if I go over down to settings and SQL databases, we can see that there's only one database attached to the server. If we had them not as single databases, but in a pool, the pool would be under Elastic Pools. Now, in this particular case, remember I've told you before that database servers are protected by firewalls. We can see these show firewall settings right off the overview screen. And we did enable Azure, other services within Azure to access this server. But if we want another machine to access this server, like our local computer, we're going to need to basically whitelist this. So in order to do this, we're going to basically have to add a rule to say that our home computer, our work computer, our corporate network is going to be allowed to access this. Now, very conveniently, Azure is telling me what my IP address is. So this is the IP on which I am accessing the portal right now. And if I wanted to whitelist my computer to access this, there's this Add Client IP button here as well. And I click it, and it basically added my local IP whitelist. So again, if your IP is not in this range, you are not going to be able to access this SQL database. And that might be perfectly fine for 99.99999% of the world that you don't want to access your database. But if your applications are, let's say your applications are mobile apps and they're going to access the database directly without a service in between, then you might have to have it wide open so the entire internet can access it. But right now, this is a firewall. We have to whitelist it. I'm going to whitelist my own IP address in order to access it. So that's sort of a mandatory right now in order for us to work with this. Okay, so the firewall settings are here. We could also connect this to our Active Directory, which is not connected. So if you don't want to set individual user IDs and passwords to log into the server, we can actually connect it to Active Directory. We can have service accounts for those applications, etc. Okay. If we go back to SQL databases and we navigate back to the database that we want to work with, right now this database does not have any tables on it. There's no way for us to insert data. We can go into the query editor, and if I was to actually provide my password here, log in, we can see that there's nothing here. Now, this isn't a very convenient way to work with SQL Server. Even if you had it on your local, if you had a web interface like this to work with it, it would be very inefficient. So coming up, we'll talk about how else we can access this SQL Server. All right, so I'm not a huge fan of this query editor inline. It's handy for some things, obviously, but I'm going to not go into that. What I want to do is I want to access this database using the traditional way, which is SQL Server Management Studio. So if you have had access to SQL Server on your local or in a server environment, you might be familiar with this management software. If you don't, I would recommend that you go find it, get it, install SQL Server Management Studio, and this will allow you to access your databases running in the cloud. So I can put in the server name. I have the server, the test user. If you remember my test account that we created when we set it up, the admin account. All right, so we're able to connect into this database just as we would a SQL Server running in our data center. And as we go in to here, we can see that we have our database into the server and absolutely no tables, views, or anything of user-created options whatsoever, as we would expect. So at this point, we can then do our normal thing, which is to create our databases or run our SQL scripts, whatever it is we want to use to configure this database. We can do this. So what I'm going to do is I'm going to set this up for our employee. So we're going to create 255 character first name, 255 character last name, and then if I click save, I have to give it a name. I'm going to call it employee. So now we have, now this isn't a great relational table because we don't have a unique identifier, an ID field. We don't have a primary key on this, etc. But this is a valid SQL Server table. We have our first name and last name. And so we've created it. It should be exactly represented within the console. So if I go back into Query Editor, log in again, then our SQL database now has an employee table. And we can start working in .NET code or whatever language we want with inserting and selecting data from our database table. Now we go back to Visual Studio. We're going to basically, in my case, I'm going to create this in the same solution that has our table storage option and our Cosmos DB option. I'm going to create this for SQL DB. Now the framework for SQL DB is system.data.SQL client. Okay, and we're going to start off with a pretty blank program, except we copied the employee entity from the Cosmos DB tab. So the same first name, last name option is going to be here. Okay. Now, hopefully because this is a programming exam after all, and connecting to a database is a fairly common programming task. We're going to basically need a connection string in order to create a connection with the SQL Server. That connection string is found in our SQL database under connection strings settings. So it gives us many programming languages here. We can just copy this. You'll notice it has space for your username and your password. But this is the connection string we're going to use in our program. Okay, so I haven't yet filled in your username, your password bit, but I will. Now, using ADO.NET to connect to a database is done through a SQL connection and SQL command. So I can create the connection with SQL connection, passing the connection string. And then if I want to run commands against this, I can say SQL command, and it requires some type of command and a link to that SQL connection. Okay, so we can say something, and then the connection would go there. In this case, our command could be something like insert employee. We've got first name, I think I capitalized it, last name, values, and we'll do this as parameters, right? So first name, last name. Okay, so the very simple command that we can use for our SQL command. Now, of course, we haven't created the entity yet, so we can say employee, entity, employee, goes new, employee entity, where employee first name equals John, employee last name equals Doe. We have our object here. Oops. And, oh, it doesn't like that. And then what we need to do is basically go to the parameter settings for the command, say add with value, and then we're looking for first name, and then we can pass in employee first name. This is a very simplistic example, I admit, but then last name, we can pass in the last name. We have to open the connection, so open a link to our database. We want to execute this non-query. So there's no results that we're expecting from this. It's just an insert. And we can basically assume that that worked, close the connection, and have a we can double check that that's actually inserted data into our database, right? So I updated the connection string with my user ID and password. I'm going to say build succeeded. Then I should be able to say start. And the program started and ran. Now if we go to our SQL Server Management Studio and refresh this, we can see our employee table. And if I said select 1,000 rows, see how quick this is. It returned to me one row, John Doe. So we just inserted this and we're able to see that the data is being returned. So again, this should be very standard in terms of database programming, working with SQL Server in your local. This time it's SQL database running in the cloud. Like I said, there are subtle differences between the two, but 95% plus of all applications should be able to just be transported by changing the connection string. Okay. So that's it. We've got our SQL database running. It's another option for working with data in the cloud.